Hey class, welcome back. If you check out the board behind me, we're going to go through today's notes. Make sure you check out the second part of the video where we go through the notes on the right side and we have some of the answers that you're looking for. Although the last answer is more kind of an opinion question, but I really want you to check that out. Let's see what we started with today. Interesting day going on. We started with CNN current events. Obviously, the presidential election and the Electoral College are in the news today. That's a really big deal. When I was about your age, 7th grade, they had told us in class several times that we had this Electoral College, we learned about it, and I remember very clearly a teacher saying, well, you probably won't ever see in your lifetime any time when it's going to come down to the Electoral College. I have now seen it twice in my lifetime where a election has come down to the Electoral College. Has changed where the popular vote is different than the Electoral College vote. So this is great time for current events and to check out what's going on there. CNN then went on to talk about asteroids, which was fantastic because we've talked about asteroids already. No notes were required on that, but we have a whole unit. We've already touched on it a little bit where we talk about asteroids in terms of their impact, get it, their impact, and also how one of them that was about 6 miles across probably led to the extinction of the dinosaurs. Finally, there's a cool little blurb in there about spiders, so do check that out. All right, moving on here. Alfred Wegener. If you look at the scientists in history that I would love to be able to step out of my time machine and talk to for a few minutes, I would love to talk to Alfred Wegener. Why? He was one of those guys that came along and said, hey, you know what? I bet, he was also a generalist. He liked a little bit of everything in science, and he looked at the map of the world and he says, you know what, I think those continents were probably together at one time. Now, like every kid in school has seen, and again, it's old news for a lot of you, but Africa, South America looking like they fit together. The problem was, in Alfred Wegener's time, he did not have a way to prove this or a way to show a good mechanism for it. He did, however, go on to a few expeditions to try and gather evidence for his theory. Unfortunately for Alfred, he ended up in a blizzard in Greenland and did not make it back to camp and froze to death in Greenland. Man, he was actually literally laughed out of a scientific convention one time too for his ideas on moving continents. Now, of course, we know the continents move. We witness it even. And when you're talking biology, this is where I love where biology, astronomy, where the sciences come together. Our main focus in this class is evolution and natural selection and how genes change over time, gene frequencies change over time. What we're checking out in here is the way that the moving continents bring together animal species that might not normally have been or might not have evolved together, or it can pull them apart and cause diversification. Also, if you check out the changing environments, Australia down here has been doing its own thing for about 100 million years. That has led to a tremendous diversity of life in terms of you see more marsupials there than you do anywhere else in the world. Other quick example that we talked about in one of the classes was Madagascar, breaking off from Africa there. Another continent, subcontinent they call it, that used to be down where Madagascar is the Indian subcontinent. Plowed into Asia. Now when I say plowed into Asia, in terms of continental speed, which we'll get to in a second up here, it went fairly fast as it hit Asia, and it ran in so quickly that it threw up into the air the Himalayan mountains. And those are the highest mountains, of course, in the world. Everest reaching almost 30,000 feet. You're talking about the height at which a commercial airplane travels. That obviously changes the environment, and we're studying evolution. You might go back on your notes a little bit. Remember that evolution is all about adapting, and if you check out the environment changing to that extent, life has to do some pretty serious adapting to be able to handle that. We then moved on to talk a little bit about the speed with which they move. This is important, about 2 centimeters a year roughly, often compared to about the speed that your fingernails grow. And we then talked a tiny bit, because again, this is all wrapped together the way the sciences come together to talk about evolution, tides on our Earth. In other words, if we look at, in chapter 3 especially, we talked about this, if we look at high tides and low tides, one of the examples I gave was surfing. You've got right here at Lindamar Beach, right down the way. If you want to check out the tides for surfing, I've got a little app on my phone that says, hey, the high tide is coming up, the low tide is coming up. Gives you the exact time on the tides. You've got 2 high tides and 2 low tides a day. Why? You might remember this. I'm trying my best to make the point that you've got to keep your old notes, your first trimester notes, because we refer to them all the time. You might remember the force of gravity, number 4 there on the list of forces. By far the weakest force of the 4 that we have listed here. But if you're talking tides, one of the most important forces, because if this softball represents the moon and this globe represents the Earth, you've got the moon orbiting the Earth once per month. We'll talk about that a little bit more on the next slide. But that causes 2 high and 2 low tides per day. Now, when you're talking tides, oh, by the way, this softball and this globe, I picked these on purpose because roughly, if the Earth was this size, the moon would be just about the size of this softball. I checked out the ratios, it's very, very close. So that's very, very cool. But getting back to the tides, when you put down these props and pick up yet one more, when you were in outdoor ed, if you did outdoor ed, chances are, although I can't guarantee it, we did some tide pooling. When you look at the tides that we have on Earth, the high tides and the low tides make it really important for life to adapt to those intertidal zones. They have to sometimes be high and dry, other times surrounded by water. And life really thrives at those tide zones. If you check out Lindemar Beach, again, I mentioned it because if you go there at low tide on both the north and the south side of the beach, there are actually great tide pools people don't know too much about. A lot of time people talk about Fitzgerald Marine Reserve, which is fantastic just down the coast. But we have a great tide pool right here in town, and I really encourage you to check that out. The point being, this is where geology, this is where astronomy cross over with biology. You've got things that are happening that force life, that help life to adapt, to change. This is where it goes back on our notes on mutation. Finally, the last part of the notes, and I'll switch the boards real quick, was a couple of questions. Now, I was challenging the students to try and figure out the answers to these questions on their own. However, I also did promise to try and put the answers into this video. Now, all of them I can't put into the video, but a couple I can. First of all, tie-ins, connections with weeks 1 through 10. Another reminder, keep those notes. If you are missing any of your notes for whatever reason, you weren't here that day, you happen not to remember where you wrote it down, the dog ate your homework, make sure you go on to pacificascience.org to get those notes. The moon orbits the Earth once per month. We already mentioned that, I think, once earlier today. It goes around one time every month. That's where the term month comes from, the word month comes from. The moon goes around the Earth once every month. And when you get the sun and the moon lined up together compared with the Earth, that's when you get your extra high tides and your extra low tides. Neap tides, spring tides, we'll talk about those a little bit later, but I wanted to throw that in. That's when they talk about the tide predictions for surfing and things like that. You pay attention to these things. A little side note, and again, this comes in a little bit more in detail in chapters 4 and 5, but remember the moon doesn't have its own light. The sun shines on the moon, we see reflected sunlight from the moon. It takes about 1.3 seconds for the light that bounces off the moon to reach us. Your challenge was to figure out, okay, well, about how far away then is the moon? You can see this 1.3 second delay if you've ever seen the old videos, and I'll try and put it on the links below. When they talk about when we went to the moon, Apollo 11, Apollo 12, Apollo 14, when we went to the moon and they show the communication between the Earth and the astronauts on the moon, you always hear this beep and a little delay. Delay because radio waves, just another form of light waves really, electromagnetic radiation, it takes 1.3 seconds for the message to get there, 1.3 seconds for the message to get back. Think about that if you were in the Apollo program, you were 1.3 light seconds away from Earth. That's pretty stunningly amazing if you imagine being on the moon and being that far away. And if you do just a little bit of the math, you find out that the moon is just about, once again, estimating is fine here, about 250,000 miles away from Earth, 250,000 miles. We're going to use miles here. And this right here was meant to go a little bit more in detail about the oceans because we're talking about tides. The moon is too small for an atmosphere. Put a little asterisk there. Technically, it's got a very, very, very small atmosphere close to the ground, but it's basically too small for an atmosphere. But our atmosphere here on Earth, If you take a big breath of air, you're getting about 80% nitrogen in that breath, but you're also getting roughly 20% oxygen, a little bit less than that. There's some other gases too, carbon dioxide and some noble gases, but if you check out where that free oxygen comes from, it's O2, it's a molecule of oxygen that the photosynthesizers literally throw off. They say, hey, we don't want this oxygen, and they toss it away. For those of us who are into breathing, kind of important, because we say, hey, you know what? We will use that oxygen for respiration. We get into cellular respiration a little bit more in chapter 7, I believe it is. But if you're looking at where roughly 50 to 80% of our oxygen comes from, it comes from photosynthesizers in the ocean called plankton. And here is one of those things where we talk about, you once again look at your key terms, look at chapter 3, we talk about pollution. Biomass, easy to figure out what this word means, right? Life, weight, essentially. If you were to weigh all of the biomass, the plankton in the ocean, how much does it all weigh? And you were to compare that with the weight of the plastic garbage in the ocean. In some places, right now, plankton is outweighed by plastic garbage. You might remember, and if you don't, please go back onto CNN 10 and check it out for yourself. They keep their archives up there for about 2 weeks. Roughly a week and a half ago, CNN 10 did a story on plastic and biodegradable plastics. Oh, wait a second, that gets to one of our answers. And we want to figure out 2 things. 35-word minimum. Again, I'm not going to count your words. It's a challenge to try and reach the 35-word minimum here as a whole to answer these 2 questions. Why is this a problem? In other words, if you have plankton being outweighed by plastic, why is that a problem? I know, if you're into breathing, you might want to think about the oxygen supply. If you have photosynthesizers being outweighed by plastic pollution in our oceans, really an important issue for your generation. And then finally, I want you to think in terms of solutions. I don't want to be all doom and gloom here, because we've got to think, hey, technology created this problem. We make plastics, we make polymers, usually with petroleum products. It's a lot of P's there. But if you want to think about this in terms of how can we fix it, I already mentioned one thing, biodegradable plastics. Try and think of some other solution, or do a little bit of Googling yourself. How can we reduce the plastic pollution in our ocean? That's our quick recap. I'm having trouble talking today. That's our quick recap of the notes for today, November 5th, and November 6th notes as well. And I will post these up on YouTube along with the notes in your Google Classroom. These are all the first notes for the second trimester. Have a great day, everybody, and I'll talk to you soon online. Bye-bye.